go find this file. I meant to do that before we started. Got distracted with some other stuff.
I believe that's everybody, right?
Yep. I think we have a quorum.
Yep.
Sweet. All right. Well, thank you for returning. Getting abused by art is never fun. So Jim sent me a little while back a data set to everybody. If Teresa has access to it, but it's mostly just for her to watch and see how things go. The rest of you guys, I think, have this data set. You're free to go ahead and click through all you like.
Yeah, I'm looking. I'm actually looking for it. Where did I store it? That's the.
I don't know, but you called it NC12, so if you search for that, you might find it quickly.
And doesn't it say like to art or something like that?
Yeah, yes. To art for training. Yeah.
Yeah, so let's talk a little bit about it. So the problem statement on this one was the Albemarle Magnolia site was struggling with some batch processes. So the way that these two processes work is you have a reactor that runs, which is the, let's see, NC12BR2511. And then you have right behind that a stripping process. So basically the reactor process ends, they pump the material over to a stripper, and that's also a batch process. So what I was trying to do in this case, one of the key questions they were trying to figure out is, okay, other than the times that we put the process in operator hold for 5 hours because we're waiting on something or because we have a breakdown or something along those lines, why is it that we can't run as fast as we do other times? Like, why do we run sometimes fast and sometimes slow? You know, all things being equal. And so one of the things that we wanted to look at was, is there something in the stripping process that's causing a problem, or is there something in the reactor process that's a problem? And so what I did was I just did a quartile, of each set of batches. So in other words, I just did I think there's even a quartile function in Excel. Basically took all the batches and said, okay, quartile 1 are the fastest 25% of the batches, then all the way down to quartile 4. And so, like, what's different between quartile 1 and quartile 4 was kind of my premise, right? Those are your fastest batches compared to your slowest batches. What actually is happening? So I did that for both the reactor batches and the stripper batches. And so what I would do to line the data up is, we knew that, like, let's say the reactor batch ran from noon until 2 o'clock p.m. And then there was a stripper batch that started at 2:01 p.m. and went to 4:01 p.m. Okay, those two were essentially the same set of material through those two, because literally it feeds from the reactor into the stripper, right? So literally I just did a little bit of lining up of the data in Excel, and I did two different analyses. One is I put all the reactor batches first, and I said, okay, what's the difference between a quartile 1 reactor batch versus a quartile 4 reactor batch? And I had all the stripper data as well. And then I think the one that I sent to Art, I think I did the stripper first, where I had the stripper batches listed first. I was looking at quartile 1 versus quartile 4 batches, and then had the reactor batches listed separate or second. So in other words, I was looking at let's say the reactor batch that started at 2:01 and went to 4:01 p.m. Then I just lined up the reactor batch that started immediately before that, right? So it just depended on how I lined things up into which quartile I was looking for. I didn't really actually have to do that, hindsight 2020, but that was just kind of how I was thinking about it. And so there's actually a couple of ways we can look at this. Is we can say we can look at just the reactor batches, just the stripper batches, or all the batches, with the stripper listed first. So anyway, that was kind of the premise of it. So and the data set is this: is each one of these batches is a Pi event frame. So basically, we get some summary information about the batch at the end of the batch. It's basically a batch record. Okay. So in other words, like what you're seeing here, starting with column G, is what's the average agitator amps over the course of the entire batch? What is the agitator amps for the entire DPE phase? What was the agitator amps average the first 10 minutes of the DPE phase? And when you see the first 10 minutes, it was literally just the DPE phase. So there's a bunch of analytics that were done, and then at the very end, we just kind of roll it up into one set of data that says, this is a summary of everything that happened in this batch. Okay. So that's kind of how a lot of times we get batch data. Sometimes we can, and we have the ability to get, if we wanted data every minute, interpolated data for every minute of the batch, we can get that too. If we so choose, to see if we want to get, look at something different. So when you're talking a batch project, okay, is it the minute by minute data of each batch, or is it the summary information like what we've provided here?
It's the minute by minute.
It's the minute by minute. Okay.
Yeah. So did I do the batch slide deck with you guys?
We have not. But I was just kind of thinking about something, like even before we get started on this, does anyone have any questions or comments from last week of where we ended up? Because the homework I gave everybody, and I don't know if everybody got a chance to get to it, but was to play around with the same data set that I gave you, Art, except I put some lab data in it just to see if it looked different. It does look different. I didn't find anything in my looking at it. I looked at their TTA test, which is a quality test, and I did an OPLS with it, and pretty much everything that lined up with it is stuff that should line up. In other words, it's just confirming what we already know. It's, like I would have the analyzer, TTA lab analyzer data, would be my Y variable. And then I would have the TTA coming out of the Slaker would be like right next to it. And you're like, okay, well, I would expect those two to track together, right? They're confirming each other, right? So I had a lot of that. Did anybody else get a chance to play with it? And were there any questions from last week before we move on?
I didn't, to be honest, I didn't do the lab data file, but I did mess around with the original file.
Okay.
And yeah, I don't know. I just I could never quite get it to look like what we did in class. Yeah, even from the very beginning when I imported my data and just did a 2-component PCA, my original model looked very different from what the model looked like when we originally did it. But I just kind of went ahead and tried to clean it up the same way we went through the steps previously in the class.
Which is kind of the big thing that you want to try to learn how to do.
Sure. I got diminishing returns. I never did quite get a good, R-squared value. Let me just launch it on my screen real quick, if that's all right.
Sure.
Yeah, go ahead.
You can see my R-squared values kind of got worse. Same with my Q values. I go back to my original model.
Well, and you're doing PLS versus OPLS too.
It's going to make a huge difference. It just comes down to interpretation.
Right.
So.
It doesn't,
Okay. But this is really where I mean, this, in my mind, like, this should have been a lot more similar to what we did in the lecture, just because I haven't done anything. I've just imported the data. I've cleaned it up a bit. Pretty similar to what we did in the lecture, I'm pretty sure. I mean, I could have missed a few things here and there, but I wouldn't think that they make that big of a difference. But, you know, I did fix that. But anyways, I don't know. I don't know if you had any thoughts, Art, or, you know, if I should be worried about that, or I just kind of slowly started cleaning up stuff like this. And, yeah.
Yeah, you have 24,000 observations, and I only had 15,000 and change. So I'm curious where that differential occurred.
Well, I think we
Yeah.
started out with 24,000 and we whittled it down.
Did anyone else have similar results to what I did? Did anyone else work on this?
I want to. Well, I didn't do that file. I did with the lab data. Had a similar pattern though.
So I cleaned up. So yeah, here I said remove 2 standard deviations. So I removed a lot of that noise out there. And then I
I
started
remember
to-
right at the beginning, we took a huge chunk off the tail on the side of the first model.
But it was off to the left, if I remember correctly, was it not? Like, it was kind of like the opposite
Yeah, it was.
shape, I feel like.
We took out a lot of the deviation, a lot of the points that were way out there.
Yeah, but what
Yeah.
Philip was saying is what we saw in class is the tail went off to the left and his it goes off to the right. I don't know if that really matters.
But yeah, so then here I think I probably would have removed all of this. And then, I mean, I kind of just progressively kept doing that until I was like, all right, I think I'm just, at
Okay.
this point, not really
Yeah,
accomplishing
I figured out what happened here. There was a whole bunch of data with like 67% missing data,
anything.
and I excluded them, and you kept it all.
Mm-hmm.
So that's the differential at the start.
Okay. So I did when I made the original model and I clicked, you know, like new model and went through all the steps. I did, you know, say yes to those prompts. Would that be the same as excluding that, or is there something I should have done on the import stage?
I'm going back to trying to create exclude these terms. I think you did no to all and no to all. Yep, that's what you had to have done. And then I'm trying to see if I get the same numbers you do. Hold on.
Yeah.
I'm doing my CV rounds now, so almost finished. Principal component 3. How many did you find?
I just did fit the first 2. I didn't do auto fit.
Okay. So I'm going to be waiting here a moment. All right, it's annoying me. Let me just do 2 first. There we go. 2. Yeah, I got 24, 9 is my count. Is that what you have?
24,
No, you
82.
have 24 82. Interesting.
But it's a lot closer than previously.
Yep. And I got a 2007 and you got a, yep. Okay.
Does your score plot look like that?
Oh, mine's worse. So,
Yeah.
not sure what's going on. But either way, looks like you did a good job cleaning up. So,
Yeah,
did
so
you feel comfortable moving through it, or did you? I didn't hear a specific question. Nothing against your. Maybe. Did
No,
you
no,
ask-
I was just trying
Okay.
to point out. I guess. I guess I felt comfortable, you know, looking at, you know, these plots and kind of seeing where, like, cleaning up down to here. I guess just at some point, like I said, I had diminishing returns. I didn't really ever. I don't know what would have been an acceptable. I mean, I guess this one's all right.
Oh, actually, looks like Model 5 there would have been okay for you.
So that, oh, I didn't even, yeah, okay. That's not bad. So that's where I would have been like a little unsure is like where to stop and where to be happy. So to me, when I would have seen that, my first instinct would have been to, clean that up a bit with all this and that. But
Yeah, if I got rid of all the downturns, but I would go back and ask what, make a note, ask what the downturns are, right? What the dips
Mhm.
are, and then remove them and say, well, I removed them. Good. I thought that's what that may have been. Let me go ahead and show you what that now looks like, right? So you can move through, make the notes, ask as you're showing the day. Well, what are these downslopes? Oh, okay, so it'd be okay to remove them? Okay, great, because your next slide already has them removed, right? So you just want to make sure that
Right.
you're asking the client, hey, does it make sense to remove these? And they goes, yes, then you did it, right? Just ask the pointed question, what exactly you ended up doing. Would it be okay would you think, would it make sense to remove these? And they go, yes. These, of course, would not be described. These would be
Right.
described as, 2% or whatever, or 2 standard deviations or greater. And then you remove them out. So you're leading the conversation in your slide presentation. So you're getting the customer to engage in your slides rather than just being data on a screen that you're talking to. He's making decisions, he thinks, about what's happening. And if it was not okay, then you have to go to like slide number 18 or something. You skip the next 3
Right.
slides. So you just have to kind of remember where you are in your deck and then skip over. So yeah, you might have to work up your data 3 times, but you have all 3 scenarios worked out and you're only taking the hour of your customer's time. So it shows you respect their time more than yours, which is consultants. They always think that the consultants respect the consultant's time more than the customer. So at least but then he knows you worked a little bit more in the background. So it's a give and a take, but in the meeting room, I always think the customer wants to have a short, concise conversation because that's where he feels he's paying for. I don't think they
Mhm.
feel they're paying for your back end work.
Right.
If you're bidding by project, same concept. You want to make sure that they see a clean display that you're not sitting here going, oh, let me look into that now. No, I looked into it and this is what we did. Now, if he gives you a wrong answer or the answer of a path you didn't follow, then you really got to start going, well, why is that really correct? Then you have a reason to start asking a whole bunch of questions, which as a consultant, you're allowed to do. So it's a
Mhm.
win-win no matter how you do it, as long as you phrase it right. Is what I'm trying to get across. And I think here your next question is how come some are like 17 and some are like 3?
Mhm.
Yeah, I have no idea. Can you click on the 17 there?
Yeah, so I was gonna say, I mean, I think some of these would look like what would need to be predicted variables, like this rolling 24-hour uptime. I mean,
Well, yeah, those are going to match because you were looking for production, how much production that you made.
yeah,
So, in other
and I
words,
think
that's
that
going to
was
be
what I
highly
started to
correlative.
do going down. Is I started to remove these variables because I want to know what those are versus
Yeah.
Yeah.
model them, and I think that's where I started to
So if you're trying
drop
to,
down.
if you're trying to predict output and all those are uptime, then yeah, they're going to
Mhm.
correlate. So
Yeah.
they would just need to go because otherwise you're correlating time with time or time with mass through throughput with mass, whatever. It's all the same.
Yeah, just for my sanity, I am pretty sure that I removed those just to show that I at least maybe knew slightly what I was doing. Where was
Well, I say here, Jim
the?
keeps saying, which we have to figure out how we want to do. This is outside the scope of this meeting. I'd like to do a LinkedIn campaign with you guys potentially,
Yeah,
or maybe do like a small webinar or something together, rather than just Industrial Insights and Sartorius. This is how Industrial Insights use Sartorius, so we can have a brief. I think if like a little podcasting and like a little back and forth, I've seen you do. Hey, why would we want to remove these? Well, and then I answer, right, and then we keep on going through. So Jim and me, Ben, and we can help broadcast that on our channels as well. Just throwing it out there as a concept because I think that would work really, really well. We need to,
I do too.
yeah,
I like
we
that
need,
idea.
we all need to get these concepts out there.
Yes.
People are just starting to get into multivariate They're just starting to understand what it means. And they are clueless. They expect to, I had this happen on Friday. They gave me a whole bunch of data. And like, okay, what variables do I need to adjust? And I'm like, well, how much do I need to adjust them? Well, there's a slider right here. I can't go much further than showing you the answer, So it's like, and even when you show them the answer, they still don't know what to do with it. Now, this is cool. So you
Yeah.
have
Yeah.
four different operational modes here, it looks like.
Yeah, so what was kind of interesting is I did a timestamp. I did it by category, and I put 33 categories so that I would basically have essentially a month.
Yep,
It
looks
didn't
like
it
you did a
didn't
good
work
job.
out, exactly. It got a little, wonky at the end, but
Close enough.
but then I could kind of play around
Yeah,
with, see how they were moving over time.
that's interesting that they're,
Here's what it tells me. They're hunting. They're hunting and
yeah,
changing stuff. Now, there were some things that I ended up finding where, you know, there was one that was like a pressure transducer, and you could tell just by the data it didn't work for a really
yeah,
long
it's
time.
drifting or something.
No,
Oh, okay, it was just
it
off.
just was
Yeah.
around zero, and then there was no data for a while, and then all of a sudden it started working, right? And so those are the kind of things you have to recognize and hear. And one of the things I always get concerned about when you see so much data that you have to pull out, where you have IO timeout configure, bad input, all those kind of things. There was an awful lot of that in this data set, and you could see it in the missing data.
Mm.
You start to wonder, okay, is the information I'm being given, from the process, is it even valid? Does their instrumentation work well enough for us to be able to even do this kind of work? And that was where my mind started to drift toward, right? And it starts to drift toward, maybe they need a data fidelity study instead of SIMCA at this point, where we can get good data, where we can teach them those principles, and then we can actually get good data. But one of the things I wanted to show was this, the color by category. I thought that was, because I was like, how do they move over time? So like when you would do it, you would just remove it, and say, I want 33 categories. And I just played with the number until I got about what I wanted, and then, so if I only wanted, 24, for instance, I got to remove these, right? This will be more like 2 months, but you'll see the coloring. I mean, it doesn't change a whole lot, but you can group it up. Like if I wanted to do it by quarter, by year,
Hmm.
there's several different ways you can, tidy that up. And that might even tell part of a story, right? So I don't know. That was something I
So,
kind of played around with.
yeah, so to me, this idea I've had in my head a little bit is if you could just use Simca to try to get them more consistent over time, then the
Yeah.
kind of variables at play would pop out better,
Well,
right?
not just consistent over time, but consistently good, even, or consistently good, or consistently bad, where you could
No,
tell the
Just
difference.
consistent. From what I
That,
heard
that's what I,
multiple,
yeah,
I want to step in. What I heard
sorry.
multiple times is, oh, don't be sorry. Um, there's weird delays, so I just learned to speak up.
Yep.
I heard data integrity a number of times. So what exactly does that mean to you, and how would that work to or against your advantage, right? So, hey, look, we pulled down all the data. Thank you. First off, thank you for letting us have an opportunity to review your data. What we did is we pulled down all your data. We noticed there's a whole bunch of missing data, but that's a separate conversation. So what we found so far is this. Does this make sense? Okay, great. Now what that brings confidence and comfortableness. That's a new word I made up, to the conversation. So if I know that if I add more sugar, I'm going to have a sweeter sweet tea, phenomenal. right? And the data shows it. It demonstrates off time, right? So I was heating up my water. I turned it off. I let it come down to 207. I poured it over my tea bags. I left it in my kettle until it cooled down to 200, and then I took it off and I pulled the bags out, and then I went ahead and I added my sugar, and I kept stirring until it was just coming together, just barely crystals in the water. Then I poured it over my ice, and then I did this, right? So you can see each of those steps in my iced tea making process, right? So we can clearly see these steps are delineated within the data, right? So we all can agree if we continue to put time and effort into this, we should get some payback. Now you got them to agree to continue doing this. Okay, now let's have a conversation about that data integrity thing, or data fidelity, which I or Tampa, I'm not 100% sure what that means to Industrial Insight, so I'm going to ask for that clarity in a moment. But let's have that conversation, because if we know that we can do the work, if we had the right data, let's go out and get that right data. Let's talk about what we may be missing, or should we be pulling in a different data stream from someplace else? Should we be adding the laboratory data? Blah 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 blah. And then, oh, by the way, 40% of your data is missing. Can you imagine what this would look like, right? And I think that's the fidelity question. So what does this fidelity mean, and how do you try to? Because I want to potentially leverage that for like a webinar, or like I said, a discussion, because we here constantly run into that, even with pharmaceutical companies. They just don't have the right tags, or they don't, or the tags they have are missing a crap ton of data. And again, that's a technical amount of data. We have to have this conversation because it constantly comes up. And so I know that it's a little bit of both ways. And I guess I'm happy to meet you guys again next week. I'm not a strict timekeeper for the course. As long as we're mutually benefiting, I'm happy to keep going. I want to know what the hell data fidelity means. I just flat out asked it. So what does it mean to you guys?
So one of the things that, one of our other partners is a company called Pattern Discovery Technologies. So they make a software package called Compression Insight. So what that allows you to do is actually do tag tuning on the exception and compression, of the actual signals themselves. Right, let me see if I can find a screenshot of what that actually looks like. Let me find a good example here. Okay, so here's a great example in that this was, I don't remember what tag this is. It's some kind of a flow transmitter. Okay.
It's like a bad EKG, if you ask me.
So a couple of things you see is, one is the snapshot data is like the green line coming in. That's the raw data coming in if you don't compress it at all. Okay. The archived data is the red line. That's what they've actually archived. They've archived 50 of the 21,600 points that have come in.
Where do you see that?
Right over here.
Okay.
So 21,600 came in, 50 were kept. So here, like right now, their exception deviation is 4 engineering units. Their compression deviation is 8 engineering units. Their fidelity of information is like 2%. Okay.
Oh my Lord.
So they've only archived 218 of all of the data points that they've gotten in, and their snapshot count is 92,813. They've archived 218 of them. Right? So they're not archiving anything. Right?
No, they're really not.
One of the other things I see is I'm like, I think you have some instrumentation issues. All these little, blips are, I think you have some kind of a weird instrumentation problem, or you got noise in the system or something like that. So
it's like a motor starting or stopping.
Yeah. So here's so this is it zoomed out. Okay, so this is what it looks like overall.
Over a long period of time.
Yeah, longer.
Oh, that's not even a long period of time.
No, that's like 5
hours.
Yeah.
Oh, jeez. Okay.
Yeah. So the thing is the red line does not look like the green line at all, right?
Yeah, I want to have this conversation with you in a podcast, because I run into this crap all the time.
Yeah. So we get into this. We try to show people, like how bad their data is. So here's one I just did for Cargill: 318,000 tags. They
Yeah, I
had,
saw that was huge.
they had 52,000 that were bad or stale. They only had 62,000 out of 318,000, only 62,000 unique descriptions. Their biggest one was the word none was 18,000 of
God.
them. Okay, here's the one I like: interlock and interlocks. Okay, there's like 1,900 tags basically that had those two. So what we do is we go and we look at the system, and we say, okay, how many tags do you have 00 set at? So in other words, you're only removing duplicates. You're allowing everything through the interface and you're only removing duplicate data, versus how many do we think you're removing way too much, which is probably in these boxes out here, right? This 1 to 10 and beyond of, what their exception deviations are. So what we do is we just do an in-depth study of that, do the screenshots. Thought I pulled this. Oh, I haven't pulled it up yet. Let's see. Let me find the final draft. And then at the end of it, and we actually teach them how to use this software, this Compression Insight software, to actually tune their data where it actually looks good. And then at the end of it, we talk about why it's even important, why compression's important, all that. Kind of give them a bottom line, and we walk through the process. Here's what we see. Anything you see in green this is something you need to take action on. So we take screenshots and things of, here's what we see. This backs up everything that we're telling you. It's very data driven. We put in some knowledge base articles on why things ought to be configured certain ways. And then, we talk a little bit about some of those screenshots that I showed you. Right? Here's what we did. Here's what difference it made. Right? And then at the very, very end, we say, okay, here's what you need to do. Right? And we give them an action list. And we're like, okay, we can either help you with it or you can do it yourself. So anyway, we try to give them, a good set of actions to go get their data cleaned up. Because and the whole reason why Paul from Compression or Pattern Discovery Technologies even got into doing this was because he saw like what I showed you, in that a lot of the data, they were doing some advanced analytics in the Canadian oil sands, and they were seeing straight lines on the screen. They're like, well, your process really isn't changing. And they're like, well, yes, it is. We can see it on the DCS. Well, your PI system's not saying that. And so he ended up building this tool that actually is now his primary product. So it's a pretty interesting set of tools that we can use. But that's what data fidelity means to us, is actually getting good data into the PI system that actually matches what's going on in the process.
Yeah, we need to have a talk. Maybe we do it through the OEM group. But we need to put this out there because we constantly get this question. I just got that question. Who was it? It was it wasn't Amgen. It was somebody else. I forget who it was. It was a big pharma, and I was asked, okay, well, we have a process. How much data do I need to pull out? We sample like every 3 seconds. Do I need to pull out every 3-second data? And I'm like, well, how long is your overall process? They're like, oh, it takes like 14 days. So I said, in all seriousness, do you really think it's necessary to have 3-second data for a 14-day process? How fast is the fastest transient do you think you're going to need to capture?
Yep.
What do you mean? I said, well, if you add some caustic at the top of the tank, how long does it take for the tank to come to that, realize the whole tank to come to realize that you added some caustic at the top? Like, oh, that's going to take like, 10, 15 minutes. And I said, okay, so let's go with 10. So 10 minutes is what is the largest, fastest transient you think you need to capture. So if I need, and now as a chemical engineer, it's 1/10 of the, I'd want to capture 10 stamps. So I want to have the start, the stop, and then I want to have 10 transients in between. So if I do 10 minute with 1 minute increments, I'm really only technically grabbing 8 increments along the way. But that's a good starting point. So why don't we grab every 1 minute data and grab it for one batch? And then I want to go out and grab the 3-second data for that same batch. Okay. And then he's like, that's going to take forever. Exactly. So the 1 minute data isn't going to take you all that long, right? So let's grab that. Let's build the model.
Yep.
And then, let's remove 50% of the data. Now we're doing every 2 minutes. Can we get to the same?
Answer.
Do we see the same plots, the same graphs? Do we see the
Probably.
same plots and graphs if I go to? It did. So you back it all the way out to 10 minutes. I said, now we're building a model that every 10 minutes. That seems to work well. So every 10-minute data to pull on average. Now here's the problem: is you're not going to capture, or the process isn't going to follow the exact same pattern every single time. There's going to be little deviations plus or minus. So why don't we just go to 10 collections every hour? That'd be every 6 minutes. We just pull data out, and if something starts a little off or a little early or whatever, we will at least be shifting a little bit around it, or split the difference and go to 5 every 5 minutes, 12 observations an hour. So we just reduced your data, but didn't really reduce the actual variation in your process by a whole heck of a lot.
Yep.
So you're going to lose, as you say, fidelity. You're going to lose some fidelity, but you're not going to lose the information.
Right. And that's what we try to do is, and I give scan class recommendations. Okay, you have a differential pressure transmitter on a key piece of equipment or a vibration transmitter on a key piece of equipment. Yeah, okay, do that every second. Right? You have a tank that holds several 100,000 gallons of material, and it doesn't move more than a few percentage points all day. Why are you scanning that once a second? That's ridiculous, right? You have a temperature that you pour the coals to it and heat it as much as you can, and it can't move more than a degree a minute. Why are you taking that every 5 seconds? That's dumb, And so you get people thinking about it, because the problem we have, and you and I know this, is certain data scientists and certain engineers just think they need all the data, period. Like, give me 1 second. I can always tell their experience, when data scientists are like, hey, I want all the data. Like, why? Or, okay, give it to me as fast as you can. Well, why? Because you're just going to clean it anyway. Why don't we figure out what the model needs to look like? And it's just, no, I just need all the data. Like, you don't know what you're doing. Because the way
a million rows of data ain't going to tell you.
Right.
Yeah.
It's not.
Oh, I did that. I had 200,000 rows. I knocked down to 2,300 rows, and I had the exact same answer.
Exactly, and we've seen that, just in the limited experience we've had with Simca as well. And so I try to knock it down to, what's reasonable. Do I need 1 minute data, 5 minute data, hourly data? For like this.
Well, the question is to make sure you have snapshot data,
Right.
which sometimes you don't get.
Right.
And that's what I have to keep telling people. If there's missing data, it's missing.
Right.
Let it be missing. If you're extrapolating between 2 points, if there's a value that you have in pi, I'll take that snapshot value that's you capture in pi. But it may not, if you're assuming a linear transition, it may not be linear, as you know. So that could really just mess up some of our answers. So then we always get into the conversation of how do you handle non-linear issues like responses and stuff like that.
Yeah.
I'm like, you just apply transforms. It's not rocket science, guys.
Right.
But anyway, so from here, what will we want to try to do today? I mean, we had a nice conversation so far.
Yeah,
but we haven't learned you guys anything.
No,
Again, new word.
No, actually, we have. I mean, some of the things that we're talking about, I think, is important. Ben, wouldn't you agree? Like, it's kind of key.
I mean, yeah, I think this is definitely important stuff for all of us. But I think, like, this type of thing, I think future conversations or podcasts or whatever you want to do with it, I think we need to explore this more.
Yeah, for sure.
But as far as today, I mean, I'd like to get in some of the batch stuff.
Yeah.
See some of the ways that's done.
I think I would too.
Okay.
So, but there's one. I actually have one other question. I've seen something somewhere where it talks about a QSUM analysis. I have seen QSUMs be very handy, and especially count data. Like, where do you guys use it, and how would we use it?
It's usually just like flow totalizers.
Yeah,
That's it.
I've seen it for like maybe sheet breaks or like looking for inflection points and things of that nature in the past. You know, like where you have a QSUM that changes directions or something like that. I mean, that can be like super like important. How is that how you guys use it?
Like I said, most of the use cases that it's deployed is we're accumulating a value under something. So it's like area under the curve
Right.
calculations. That's about all we're ever using it for
Okay.
directly. Now, there are clever ways to deploy it. I mean, it's just math. So if you're creative with your math, you can use it however you wish. Um, to make the QSUM is redunculously simple. Um, so I can show you how to do that. I
Yeah.
wanted to show you batch if we're going to do it.
Yeah.
I'm trying to find the old school batch course. Is what I'm looking for right now.
Okay. Yeah, I think
I
batch. I
hate
think
the
batch would be good, but I would like to see QSUM because I've seen that be very handy. We can,
it's ridiculously easy. Don't hang up on that.
well, I know that, but that I'd still like to see how it's done and like kind of
Oh
think up
yeah,
some
yeah,
use
yeah.
cases. Because I think for like sheet breaks or fault detections or things like that, I think a QSUM could be super important.
Yeah, I'm trying to data organization. I think this is the one I want. This is probably yeah. This I think is the one. Yeah, this is the one I want. Okay. Share my screen. Do. This is old school. I do not like the new slides. We have new slides and they don't work. And I can send you these after the fact or just email it to you when we're done. You do not need this on the way through. There's nothing super special here. So I think this says we're still part of Sartorius. Yeah, this must have been when we first got acquired. I'm trying to see if I can pull the date real quick on this one. Yeah, this is a year, not even a year after we were acquired. So, all right.
So you were still Umetrics at the time.
No, we were acquired, but it was under a year. So,
Oh,
so we started off as Geometrics, and we were acquired by MKS. Okay, so that's
okay.
meter kilogram second, MKS, and we were Umetrics. Then, while I was there, we got transitioned. So I was only there for 6 months. So a couple of months into the job, starting the new year, starting in October. So starting the new year, we were going to come. Was it a data MKS Data Analytics was our new title. Basically, they were trying to sell us off. So they wanted to sell, instead of selling off Umetrics, they wanted to sell off this division of their company. So our name got changed. So then we were acquired by Sartorius, and then we became Sartorius Data Analytics instead of MKS Data Analytics. But everything was still branded Umetrics because we only were Umetrics not even 6 months prior. So we changed our name, and then we were acquired and changed our name again, all within 6 months. So it was hilarious. Who are we? So what day of the week is it? Because we were changed hands so quickly. And then we've had like 17 branding changes within Sartorius, and God forbid you use the wrong slide deck. They yell at you. I mean, they're German, anyway, Germans are nothing but annoying. And I don't care if they know that I think that, because they know that they're annoying. Anywho, so this is like, I don't know how 4 years old now, this deck, but it's the best deck that we have. So we'll get this done in about a half an hour, not even. So then we could take a break and then come back. So we're going to talk the modeling strategy, defining a process, your different data sources, how to organize your data, very important. We'll hit home a little bit at the work set and data set, and we'll be done. So some of these chapters used to be really, I'm trying to switch to the other page. Yeah, this one is like 28 slides, so it's not too bad. So first, you got to define the process. So I think that's where we have a disconnect, Industrial Insights and Umetrics right now. So we need to make sure we define these processes. I think the rest of this stuff you guys are fairly well aware of. And so we define a process like this. This is all batch. Okay, so this presumes you know the multivariate course, which we've already done. Okay. How many phases? So phase is like a processing step. So we just call it a phase. And whether we need to split or merge or things on those lines. So you can have as simple as a 1 unit done. There's my batch. Everything comes in, everything comes out. Done. That could be a batch. The start of the batch, the middle of the batch, the end of the batch, they could be 3 separate batch models. They could be one large model with 3 separate phases. It all depends upon what you need it to look like. I could have 1 unit, 1 phase, second unit, third gets split. You got the idea. I have 1 going to 1 to 1, 1 going to 2, and 2 coming back to 1. Whatever you have here, we have, I believe it's 4. Let's see, unit, 4. We have 4 different levels to an onion, and they're allowed to do whatever you need them to do in terms of touching each other. So data can transmit back and forth. It's not just a one-way street, all that good stuff. So in other words, be as creative as you need to be to model it. All right. So yeah, you guys are familiar with this. So we do have the historian at the DCS level, your overall historians. This would be like your delta V. This would be like your pi limbs here. I'm not sure what systems are out there, Discoverant. And then you have another limbs. I guess this could be, I don't know what that would be, electronic notebook of some sort. Could be that limbs output. Right here, you guys are way more familiar. Now here's the most important slide for you guys, and again, I'm going to get you, I'll just forward this when I'm done. This is what a batch is to us, okay? I have a start condition. These are my inbound raw material, my media composition. That's never going to change. My media at the start is the media at the start, right? The crap I throw into the pot, my carrots, my celery, my onion. If you're from the South, your bell pepper instead of celery. And you got yourself your Trinity or your, was it Mawson? Not Mawson Plus. I forget what the other one's called. So anyway, that's the starting stuff you throw into the pot. Then we start the process. This is your runtime data or real-time data, right? So I have my timestamps come through here. So those are all my process parameters. I can then tie it up with my spectroscopy data. And I could tie this up here with my, every 4 hours I pull off whatever I need. So this could be like your K values you get off your roller. This would be the actual roller itself, right? That machine, this would be your K values. And this could be the laboratory confirmation of whatever, fiber length or something like that, right? So all these can then be pulled together. You can start to see they have different timestamps with each of these. And then finally at the end, you have your final quality parameters. So the goal typically is to release from one step to the next step or to get through this batch and have an idea what your end is going to be so you know whether you want to keep it, reject it, or throw it into quarantine. Right, so we know it's good, release it. We're not sure, quarantining or this thing ain't gonna work. Let's just rework it. You gotta throw it back at the start and start all over again. Now this could also be the start so if I'm going through a paper mill, this would be like your chipper, this would be like your digester, this would be your, whatever the heck the next steps are, right? All the way through to the paper roller. You can marry all these things together. You have different starting materials for each of the individual phases. So let's say that's phase 1, phase 2, instead of being batch, phase 3, phase 4. So as you describe your whole process and you try to understand what's happening, we can marry all that together. So for us, the data structure is the same. It's going to be dependent upon each individual model. So whether the model is an entire phase, a model is a portion, the entire process, just a phase, or it needs to iterate and need to run the same model 3 times and then moves on. All that is just, all these are individually defined by model.
All right, I have a question already.
Sure, go ahead.
So, let's say on the process parameters, let's say like in my example, we grab data once a minute for the batch as it's running. Mm-hmm. Okay, for like right. B1, for batch 1. Right. Okay, what if this, and then so let's say that batch lasts 2 hours, and then I have batch 2 that I grab 1 minute data, it lasts 2 hours and 10 minutes. I get one set of data that is spectroscopy, easy for me to say, for those 2 batches. I may not get
Just one?
I may not get spectroscopy for every batch. Is there a way to deal with that? Because usually,
Yeah.
because LIMS data, sometimes they only sample, like every 4 hours or every 8 hours or something like that. So you almost have to make an
right.
assumption of, okay, is the lab data that I'm getting right now, does that apply to the batches I'm about to make or the batches that I just made?
Yep, that's the lagging we discussed.
Yep. So spectroscopy, how do I line that up when I don't have a 1-for-1 relationship potentially? And
Right,
you don't have to
you
answer it
never
now,
really get
but-
a 1-for-1.
Okay.
No, you never get a 1-for-1.
Okay.
That's part of the discussion that we're going to have in a moment
Okay.
anyway.
All right. Cool.
So you can handle it in any number of ways. One, you can handle it as a hierarchical model, where I build a model just for spectroscopy, and then I pass up the scores up to the other model. When we do the original data, right, you have historical data you're collecting from. What if I grab all this data and I run the batch analysis, right, and then I grab just where they grab the spectroscopy information? Can I tie back enough to have an individual model for the batch, or do I have can I build a spectroscopy model across multiple batches that I can then feed back into here and then have an accurate model? The last one is that's about it. Those are the only 2 ways you can really do it.
So Ben and Katie, when we talked to Michael Wolford at Albemarle, did he have a spectroscopy plot for every batch, or was it sampled every hour? Or how did they do it? I don't remember catching that. Did y'all?
I don't think
don't
it was
think
for
he
every
said.
batch. Go ahead.
I don't think he said. I don't remember.
Ben, what'd you?
Yeah, I think it's just whenever they. I don't. That's part of the thing is I don't think they have a very set system. It's just kind of maybe when they suspect something.
I think
or
it ties to
when they
their.
get a free moment.
I think it actually ties to their LIMS data, because I remember him saying how they get their LIMS points is, they want to look at parts per million, save the oil and grease problem, right, that we've chased. Is they'll look at a certain wavelength, like a certain band of wavelength, and they'll plot the area under the curve and say, okay, the area under the curve is this, so therefore it's this many parts per million of it. So my suspicion is it's for every 4 hours, which is what the lab samples are.
I'm not sure it's that consistent, but I know that's what they store in their LIMS system. That's what they look at is a summarized number of certain parts of the wavelength. They don't really look at the whole spectra, I don't think.
That was what he was saying.
Which is what would be more likely trying to do.
Yep. Okay.
Yep.
I didn't know if you guys remembered. I was thinking it was no real good way to. Well, we know a time stamp of when that data was taken. Like when the sample itself was taken. My suspicion. So we can, as long as
Correct.
Art gives us some ways to kind of line it up. That's what we got to keep in mind.
Oh yeah, that's not a problem.
Okay.
You guys know Michael Roberto?
Yeah, we do.
Yeah, well, he now works for us. So if you have any real questions about that as well, just reach out to
Yeah,
him.
and we've already been in contact, and we were going to get in contact with him after the conference, but then we had this training, so I kind of wanted us to go through here.
Yeah.
I think after this week, we can probably reach out to him again, Katie and Ben, and say, okay, what do we need to get from the customer, and maybe even ask Michael for some spectroscopy data, for some time periods that he's got concerns about. And then we can go pull some data. It's not going to be the event frame data, though. It's probably going to be, 1 minute to 5 minute data, I would expect, on those processes.
Yeah. The data you're going to get. Okay, that's not rocket science on that statement. The question is, what can you do with it? That's where it starts becoming not rocket science. It just starts becoming a a process of elimination. Well, I can either do it one of two ways, which you can test both ways, or just with experience, you get the best guess. Now, because and not because Teresa's here, but Teresa, if you're listening, this would be the quotation for they buy like I'm just throwing a number out there, like 5 days of consulting. So that's 40 hours of consulting, and then basically we would just invoice. You'd send us a PO, and then we invoice you based upon the number of hours that we've worked in a. We agree to it every month, every quarter. We'll just send you an invoice and you pay back the consulting hours. And we would obviously discuss with you, hey, look, we just talked for 2 hours. We're going to bill you an hour and a half because we bullshitted for a half an hour. And they go, fine. And then in an email, we agree is an hour and a half. And then those get added up at the end of the month. And then we submit. That would be I think, a beneficial arrangement, but we had to have a discussion about that. But I think that would work. We do that a lot at the start of a lot of longer term, mutually beneficial, especially nothing against your situation. You got 4 new guys coming in, trying to get them up to speed. You're going to need to bounce ideas or have somebody help manipulate your data, or ask very specific question with customer data, right? So we're going to need to have probably a fairly tight relationship for a number of months.
I
and then
agree.
it will get looser over time as you guys get more and more comfortable with it. Our goal is for you to be able to run on your own, not for us to hold your hand, but we need to get paid. Now, the other option is, mutually beneficial. And again, discussions, do we just exchange our consulting and everything else for, hey, that's a great idea. Let's do a presentation on that, or let's do a webinar on that, or what can be mutually beneficial? So we're spending our time together coming up with something that works for both of us to learn, and then we can put it out for the world. So again, that's a discussion. I just want everybody to hear, we normally, I'm not that guy. I think you know me that by now. We normally charge a crap load, but if we can work something out, it's not going to cost you as much. We all benefit and we all get some publicity out of it, and we're up and running. Because for us to find good stuff to talk to, real world applications is challenging to find. So if you have those situations, you can anonymize the data or whatever you can say. That helps us tremendously, because we really are constrained, as you know. Confidentiality agreements really tie our hands. We really can't talk about half the stuff that we find because we just can't.
Yeah, we have the same challenge, but I've found ways to do it. But everything you're saying conceptually makes a lot of sense to me.
Cool.
I think it's probably, like you said, some combination of maybe a little lower rate, but we also with the stated goal of, hey, we need to do some things where we're educating the masses, where it's a mutually beneficial thing. It drives more business for each of us, kind of a
Right.
thing. But you can't do it for free. You gotta get some money back for the work you do with us, right?
Okay.
So,
That's another conversation, man. And you and I obviously can have the conversation now, but
yeah, but I agree in concept. I don't know what it all looks like, but I agree with you. I
yeah,
hear you.
okay, cool. Hey, look, there's a starting point. So as we've discussed, you have your 1 minute data, you have your 12-minute data, and then here you have your 4-hour data, and then you have your end of the batch. So you have start, end, 1 unit. That's, I think, what you were trying to show me earlier in that big Excel sheet here. I have batch data, but this is all the data I have for that one batch. That's not really helping me.
Yeah, it's basically the
What I
end.
need-
The end. It's
Yeah.
it's the column on the right. It's the end.
Mm-hmm.
This is what all went into it. So
Yeah, so you're really not, yeah, but I don't have all the information here in between. I may have the
Correct.
starting materials. I may have a couple of positions in here, but all I really have is the end spot, because it's all been, now if it's all been spread out and I need to stack it vertically, that's another conversation. We can look at the data structure, because I think if you had the time was a time at 10, 15, 20, 25, that would be, if that was stacked vertically, then I could use it as a batch, rather than you spread it out horizontally. Now, if you spread it out horizontally, we have to label it slightly differently, in order not label it, but we'll have to treat it differently. We'll get to it, okay? Because the data structure is important here. So we need for Simca to do its job, and we are the best that there is for batch analysis, okay? Period. All right. You go ask anybody. All right, it's not just me saying it. So you have batch one, then you have the start and end of your batch. Then we have the different data sets. These are all different timestamps. As you say, I have 2 hours, 2 hours, 10, hour and 50, 2 hours and a half. No problem. We can manage all of that. It's really not a big deal. What matters is the data structure. So everything's got to be stacked vertically. So timestamp one, next timestamp, next timestamp, next timestamp has to be monotonic, one direction only. I can't go backwards in time. So everything's got to be stacked in this data set. This data set, everything has to be stacked monotonically. Everything in this data set has to be stacked monotonically. And then the start and the end are what's called batch conditions. So this is the condition at the start. This is the condition at the end. Okay, so normally these are like a quality output, and these are your inputs, whatever they look like. Okay, so that's the structure of the data. And trust me, this stuff looks messed up all the time. Okay, so it's just a question of tinkering until you figure it out, honestly. It's not trial and error. It's just mostly, okay, well, it's a little bit of trial and error. Okay, well, we know it's either, like I said, 1 or 2 is going to work. So let's try 1. And if it works, let's just check that 2 doesn't really do what we want. Or we check 2 and they both work. Then you got to go, well, one of these shouldn't work. So what's going on here? Right? So it's just a little bit of double checking, making sure you're not insane, because things only really work one way. The data will tell you what it needs. It's just pretty obvious. The data tells you what it needs. So we'll get into it in a touch. Okay, it's really not rocket science. It's really not hard. It's not a challenge. This stuff's easy. Okay, it's just getting it structured correctly. Once you have it structured, it's easy. So the structure here is, here's my batch. So you have a batch ID. So that's like batch BA in this instance. I'm starting here at 11 hours and change, and I run all the way out to just under 14 hours, and I start over again, and I run all the way through. I have the, so that's going to be the age of the batch, and then here I have the ethanol and all the other different parameters, and then here I have what I started with, which is the amount that I inoculated at the start for BA. That's just off screen. And then where's CA? CA is not even here. It should be, anyway, they're not here. And then I have my quality parameter 1, quality parameter 2. I have the amount, and then you have your yield calculation. Right. So I can go ahead and pull all this information. And so there's going to be 2 different data sets. One is going to be the process data. The other one's going to be your batch conditions. If we had spectroscopy and other stuff, there'll be other data sets just labeled spectroscopy and other stuff. As you know, you can name it whatever you want. So it's stacked like this. So you have the first batch and the second batch and the third batch and the fourth batch. Each batch could have its own data sheet if you wish. So each one could have its own data set. That's fine too. It's just going to be a lot of clicking. If you have a lot of batches in Simca, because you're going to have to manually click every single one. There's no click all feature for data sets. So you're better off merging at that point in time. As long as you have all the variables are identical, you should be okay. So remember, now we have N is the number of batches times the number of time points. So the number of time points you have, let's say it's 10, and I have 10 batches. I now have 100 rows with 10 batches of 10 time points each. So that's what your new number is. K is still your number of variables. We need to have a batch ID, and it has to be unique for each batch. We need your process parameters, the time or age or maturity of your batch. And if there's any particular phase number, or if there's more than one phase, we need to have those then listed out.
All right. So quick clarification here. Okay. Did you say that you need like an equal number of rows for each batch?
No.
Okay.
No. That was just an example.
Okay, it was just an example because I'm thinking, like let's say the data that I handed you, right? I could have taken, let's just say 5-minute data for every batch. Like you'll see a batch number. I could take 5-minute data for every batch, and I would get a different number of rows, but I could tell you what everything was going on during that time. Mm-hmm. Okay. All right.
That's totally fine.
Okay. All right. Good enough.
Yeah, plus or minus 30%. So if you have 100 for your average, you can go down to 70 and up to 130, and it's really not a problem. Much beyond that, you're getting back into your fabricating data.
Well,
Or
sometimes the issue is they'll sit in operator hold for hours.
yeah, I know. There's ways around that if you have event frames running.
We do.
So yeah, then that usually isn't a problem because you don't normally use time as your maturity variable. You use elution or you use a flow, as you say, a Q sum, right? So if I Q sum a flow, if the flow's halted, right? The operator stops something. Q sum's not advancing, so in my model it's not advancing. It's just sitting there in the tank. Now the time could be going forever, but that's not. Now, what you also have a tendency of doing, and you should do, is pull the timestamp associated with each maturity variable. So that way, if you have a halt, we had an example at a pharmaceutical plant. So one plant was run in Spain, the other one was run in Puerto Rico. Now, in Puerto Rico, they would go out to lunch, come back 45 minutes later, and they would then get back onto the process. Whereas in Spain, lunch was 3 hours. So they had the same exact process. They stopped at the exact same time, but that whole time made a tremendous difference in the quality. Turned out 45 minutes is way better than 3 hours. So the people in Spain were not very happy that they couldn't take a 3-hour lunch. So they had to go back to Spain and go, hey, you guys got to change the way you're doing this because we just got some data here that says you can't wait 45 minutes or start your batch so the 3-hour overlap doesn't land at this particular processing step. So basically they just shifted the production to a start on a different shift. And so then like the first shift people got upset because they always were the most important. They always started everything, right? Nope, now it's got to start on second shift because your first shift people take that 3-hour lunch. So how do you work those things out? That's not for me to figure out. It's our job to help them figure out that siesta time made a tremendous difference in our outputs. Because when we plotted out the timestamps, not just the evolution here, but the timestamp, because this is hours in the process, not the hour of the day. So you can just have your a QSUM. Well, QSUM can't work that way, but for time, but you got the idea. So as you already know, your controllers, actuators, all that fun stuff goes in. Batch conditions are your set points. If you have a starting set point, raw materials, any different quality outcome here is your quality attributes. One column has to contain a batch ID. That I can't stress that enough. The number of N now is going to be the number of batches. So the number of observations is going to be the number of batches times the number of rows per batch. And then the number of K here is going to be the number of variables. And use the select good batches for monitoring. So what we want to do is create, if we're going to monitor, make sure the process is running the same way. We want to have a very, very narrow distribution of batches. And if we want to predict, we want to have reasonable and maybe some slight outliers to what you normally would like to operate under, because we need to have the ability to predict through the normal operational space. So if you're predicting, you can't use just this normal operational space to predict itself. You need a little bit more data outside of it to make sure you've captured that space accurately and you've captured enough variation through that predictive space. So when you're trying to capture your process and you're trying to stay within 2 standard deviations, it's okay to pull in up to 3 or even up to 4 if it makes sense. If you're not like in an outage or there's deviation associated with that, then don't do it. But you need to have more spread in your data to do accurate predictions. So it's okay. So remember the good, the bad, the ugly. It's okay to have the good. It's okay to have the bad, but it's not okay to have the ugly. So you got to kick it to the curb and you got to keep just the good and the bad. Because that's going to allow you to build a good prediction model. But normally most people just want to have the golden batch, the good batches. They want to monitor to make sure it's the same. You know how to pull stuff from a database. So raw data analysis and pre-treatment. We need to verify the data is true, that we've adjusted it, and we get rid of all that unrealistic data. So that was the trimming and Windsorizing we were discussing the last couple of times. Yes.
You said you know how to pull stuff from the database. I think that was the previous slide.
That one here.
Oh, okay. I thought you were connecting something for a second there. Oh, you can connect directly.
Oh yeah, you can connect Simca directly to Pi or any of these different Brimrose, Bruker, SPCs, all that fun stuff.
Is that something we could find out about? I don't know, Jim, if that's outside the scope of stuff we want to talk about.
I'll show you right where it is. It's going to take 3 seconds. I'm not kidding.
Okay.
So right here, data set from database, and then there's all your connections right here.
Oh.
When it's time to do this, this is the time you guys paid, I think, for 4 licenses. That's the time to call Arch. Okay. I will step you through this. Okay. I can't do it here. It will crash out my
Okay.
system because I don't have a Pi system on the back end. It's going to go look for a server, and there's going to be no Pi server. So it's
Yeah, and
Okay.
that's
I end up in an endless loop, and I have to turn my computer off and back on.
yeah, it's
So
one
I've
of the
learned not to
issues
do that.
we're going to have too. Is we're not always going to be able to connect directly to a customer database. So a lot of times this is why we try to prove things out using data we've pulled and put in Excel, because that's an easy one for us to work with. And then if, we want to, customers like, hey, I really need this. I want to do it. Well, then we can work through that. But this is why we typically work in Excel.
Yeah, I wasn't sure if this would be applicable for the Project AI stuff.
It certainly could be.
Okay.
Certainly could be. And
Yeah, the hardest
I
part.
don't know that they're doing
Sorry.
batch analysis, not from what I've seen. They're summarizing everything and doing regular projects from what I can tell. I haven't heard anybody talk about taking actual batch data. We'll see, but
Yeah, I just meant with the connection
right,
stuff.
gotcha.
Okay.
Yeah, the connections are going to require you to have logins, and usually it's a firewall issue, all that fun stuff. So the odds of you actually getting access, unless you're in the company, is fairly low. Now, if you happen to have like access to Pi and everything else, your logins and credentials, you can use those within Simca. You're only going to get snagged, and you will get snagged at the firewall because Simca doesn't have a right to touch this. So it's going to see this program trying to touch, even though it has the right credentials, the program doesn't have the credentials or doesn't have the rights. So you're going to be talking to your customer's IT department to go, I want to use Simca to pull it out. And they're like, well, can you just use the exporter? And you're like, yeah. And they export it to Excel, and then you import it into Simca. It's easier to do it through Simca to do all the updating and everything else, predict, repredict, all that fun stuff. But the odds are you're not going to get the access to it because you're going to have to file an IT ticket, and they're not going to want to do it. Unless you really know those IT people well, they're probably not going to help you. I've been around that block too many times, so as I'm sure you have too.
I think Albemarle, we could probably get that done. But yeah, I think that's something for us to dig into at some point, or like us individually.
Something that does work. Ask if you can have a virtual computer with all the given rights, and then you can dial into that computer.
Yep.
And then use
We
that
have access
virtual
to the.
computer.
Yep.
Yeah.
Exactly. We have access to a SQL server that hits Pi, so should be able to
Whatever
get to
that
it.
looks like to you.
Yep.
I do that with MSU. I have access to a J&J. I have a similar system. Access to Pfizer, Takeda, all those companies. We have that. We log into a virtual computer. I have my little login. Someone will send me the RSA key, 2293. Crap, it changed. And you're trying to get it in on time. Yeah, I have that for a couple of different companies. So, it's doable, but it takes time. And the reason why I suggested the virtual machine is they own it, they control it. It's fake. It's virtual.
That's
and
usually what we get from a company.
Well, it's perfect because then you say, I need to control this, and this, and they physically give you a physical RSA key because they want Art, not Jim or anybody else have access. Now, if you happen to give them the code over the phone and Jim's dialing in, that's between you and the contract you signed. But they really just try to limit access, is what I've learned over the years. Anyway, you guys know more about that than I do. So we have raw data analysis. We've talked about how to manage that with your trimming and Windsorizing, culprit values and offsets, all that fun stuff. Again, we've discussed that. How to apply to a data set or a work set. I always recommend just applying to the work set. Applying to the data set makes 0 sense. Configure now, unless you're trimming out the data set at the start. I just want to get rid of all the off time in my data set. That's a valid use of it. Then go ahead and go, okay, when flow is equal to 0, so you collected all the data, you have it in Excel, and you're like, I'm not going to clean it up in Excel. I'm just going to import it into Simca. Once you have the data set in, you can just pull up that on-off flow and just delete all the rows out at that point in time. And now you have a nice clean data set to work with. So that is a valid use. I do that quite a bit because I'm just lazy. I don't really feel like going into into Excel and trying to figure it out when I can just take a few minutes while a cartoon, like I watch like a rerun of Rick and Morty, and I'll sit there and let the data run at 9:30 at night. It doesn't bother me to do some basic cleanup work, and the next morning attack the data set. Configuring the maturity. We talked briefly about that, but sometimes it's just trial and error there too. How to manage the work sets, generating variables. Like I said, we'll get to that. We'll get to Q summing right there. And we've already talked about how to scale the models. So we'll take this is a good point to take a break. You guys getting hungry? You want to go for about another, we have 15, 20 minutes, or do you want to take a break here? It's been an hour and 15. It's up to you.
Yeah, I'd say we take a break real quick.
Okay, we'll start back here. What do you want to do? Want to come back at 30, or you want to go a little longer?
Yeah, 12. Let's say 12:35. It gives us
12:35.
gives us
You
20
got it.
minutes to grab a bite and all that.
Okay.
Sounds good.
All right.
All right.
Cool.
See you guys in a bit.